Hey guys, so yesterday I've hosted a special test live stream in which I was given a challenge to create a clone of the Stack game by Ketchup, which I think was the #1 game on Google Play Store last month. And so I did, and it took approximately 2 hours 30 minutes to create and publish on the Google Play Market. Here is the game that we've made during the live stream. Some of the polishing elements were added after the stream though, such as the sound and the background gradient. So the whole thing was recorded and I've decided to share it with you guys. Now this is a really different kind of video and I'd like to have your feedback. Do you like these kind of videos? And the reason I'm asking is because they're not easy to make, but they're, you know, it's a live session. Yeah, no, never mind. They are easy to make and I can actually cover a lot more, but it's much faster and well, you know, the coding is really fast paced and sometimes I completely stop just to think about how I'll tackle a problem that just popped or something like that. So guys, this is basically a video on demand. Just remember that this is from a live stream and give me your feedback. Anyway guys, enough explaining and I'll just roll the footage. Cheers. Hey, what is up guys? Welcome to the first actual live stream of this channel. I know it's a bit random and it's a bit out of the wood, but I've been promising stuff to people, such as help them make games. And you know, I keep getting more and more messages every day now that the channel is getting a little bit more popular, so I found a good way I could do this is by simply making a live stream. So I can be answering a question directly, or I could be making games. And basically recently on one of my recent videos, the endless tutorial number 4, I've got a comment saying, well, thank you, but I'm making a clone of the Stack game on the Play Store, but he's having trouble making it. And I've pretty much just replied saying, then just keep looking on the channel for a little while. I'll probably have a video explaining a little bit of that mechanic because I thought it was a really simple game and that we could simply make it. Now I could be making like 10 episodes on this or so, but I think that's a little bit too much and spamming the channel with 10 episodes. I'm more or less against it right now, so I've just decided to make this live stream right here and we'll make a Stack game from start to finish. So let's take a look at what we're going to be making at first. We are going to be making a game just like the Stack game, and let me just mute this sound. It's going to be pretty much just this thing. We're going to be publishing it as well on the Google Play Dev Store. Maybe add some little ads that I'll turn off, but I've also had a question about how do you make ads, how do you put ads on your games. So I've got my coffee and we're pretty much ready to go. Also written some algorithm on this piece of paper I've got in front of me, so we won't have to do like all the mathematics stuff because I've got all of this written down right here. Right. So there's a mechanic in this one, as you could tell. We just go back a little bit. So you've got this moving tiles and you gotta stop with a click, a touch. At the moment they're stacked on top of each other, else you lose a little part. Like, let's wait until he fails. There we go. So as you can see right here, he loses a little part. Like so. So we've got to be thinking about that. We've got to be thinking about the scale of this thing being reduced. Also the color, why not? And we just gain a score. So what I was thinking about is just we're simply going to boot a new Unity project just like this one, and we're gonna go ahead and just try our best to make this work. So since this is a live stream, I'll try to explain everything as much as I can, but sometime I might actually skip some step. I might actually not explain everything I'm doing because it's going to be really math heavy, and I don't speak English, so that's a little bit annoying for me to explain everything because I gotta be translating in real time. Right, that's my excuse. So I'm gonna go ahead and just create a scene folder like the usual stuff. So scene, script, and by the way, sorry about the English if I misspell some stuff. And I am going to save my scene. Let's make this a game scene. Now, when I was looking at the actual preview, so this thing, I was wondering, okay, so what should we actually move? Should we move the camera or should we move the stack? And the more I think about it, I think I'm going to be moving the whole stack instead, and just keep my camera at a fixed position. Now, why am I doing this exactly? I am doing this so I can quickly prototype my stack script, and you'll see why in a moment. I've got everything planned out in my mind already, so I'm going to go ahead and just create a new empty game object. Call this one the stack. That's really official, right? Move it at the origin. Let's put a nice icon on it. So there we go. That's our object. That's our main object for the whole game, actually, which is kind of annoying. I don't like having everything on a single object, but let's do it. So add component, the stack, or stack manager, but I feel like writing that down right now. So the stack. And if we go fast enough, we shouldn't have any other script, only this one, and that's not really considered like nice coding, but I mean, we're trying to do this as fast as possible. Okay, so let's think. The first thing we need is blocks, right? Let's go ahead and just get some blocks. So what I was thinking about doing actually is having them already spawn on our object. So I'll just go ahead and instantiate some cubes. Say 0, 0, 0. And let's go with, how many do they have in the game? I'm going to come back to this screen quite a lot because I want to be able to, you know, look up some stuff. So if we put that on full screen really quickly and we take a look right here. So they seem to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. About 12 tiles on the screen at the time. So let me just go like this. So now we've got 12 cubes. And just for the sake of it, I'll just bring them down of each other like that. So that's number 3, number 4, 5, and let me just bring the rest in one go. Okay, so that's what my tile is going to look like. No, my stack is going to look like, actually. So next thing we need to do is actually put all of them inside of a array. Because I'm going to be reusing this cube, I won't be reinstantiating them like we did in the endless runner, since I'm doing this fairly fast, and I'm not putting like a beginner theme to that. I'm just going to go ahead and just code what I have in mind. So let's start with a private game object array. This is going to be the stack. I'll simply leave it like that. What else? We could go into start and actually assign every object that we have in our children as a stack object as well. So let's go ahead and just do a well, let's actually instantiate the array first, right? So the stack is equal to a new game object array of type, not of type, but the size is going to be transform.child count. Right. So once we've got our array, I am going to go ahead and just fill everything in it. So for each transform t in transform this transform, then I'll say dstack at the index. That doesn't work. Okay, never mind. For int I is equal to 0, as long as int I is smaller than transform dot child count, then I++. Then I'll do dstack at the index I is equal to transform dot get child at the index I as well. Okay, so basically right now we've got our stack filled, and okay, that's actually pretty much it. Let's go ahead and create a condition right here. If input dot get mouse button down, mouse button 0, so left click. If we hit the left click, let's go ahead and just place a tile. So private void place tile. This is annoying. Okay, right. So let's put the place tile right there, And whenever we hit something on the mouse button, whenever we hit the left click, we are going to go ahead and just place one tile. Now they're not even moving just yet, but I just like to start by stacking them on top of each other. So that's going to be the first step. For this, since they all have a, well, actually, I will be putting them off on a scale y of 1, so they're only going to be 1 meter in height every time. So since this is going to be the case, I'll just go ahead and use a int that I'll also use for the score to calculate their position in a y. So private int score count is equal to 0. And whenever I place a tile, I am going to say the stack at stack index, so we need to keep track of the index, dot transform dot position, or actually let's do local position since we're moving the whole stack, is equal to, and then we're going to do a new vector3. Of course, this is going to change by the end of this. Score count and then 0. Okay. So we also need a stack index. Private int stack index is going to start on, should it start on 0? I'm thinking about that really quickly. It shouldn't start at 0 because when we've made our array, it's going to go like this. So this is going to be index number 0, 1, 2, 3, 4, 5, 6, 7, and so on. So when I actually want to put something right here on top of that, what I'm going to be doing is taking the one down here, the one at the very bottom, and then bumping it back up here. So the stack index at this point should actually not be set, and in the start, we are going to say stack index is equal to transform.child count minus 1. So we're starting from the bottom basically, and we're going to be reversing that order. So every time we use a tile, we're going to do stack index minus minus and then go on from there. Okay, so let's take a look at this right now. First, we have an error, so we're going to go fix that. Transform the getChild.gameObject. Okay, and we never increment the score, so that's another thing I need to do. So in the update, I'll actually put that in brackets like so. We're going to place the tile, and after placing the tile, score count plus plus. So let's go with that. And what else? Okay, and we never reduce the stack index, of course, but we have something of the sort for now. Let's go ahead and just we're going to be placing the tile, but I don't want to be just placing the tile. I also want a function that is going to spawn a tile. So private void spawn tile. And those two are going to be fairly different. So if we just take a look in the spawn tile, I want to be doing that's actually where I want to be moving the position. So I'll be taking this, moving it up here. Placing the tile is going to be on the moment you actually press on the button, and then it has an action depending on whether or not you actually landed correctly on the thing. So in spawn tile, I'll be doing stack index minus minus. If stack index is now smaller than 0, that means we need to bump it back up. So stack index is equal to transform.child count dot actually minus 1. Okay, let's actually try that. Okay, so I'm in my game screen right now. I'm pressing on the buttons and nothing happens because I've actually moved the function. We're going to be spawning a tile instead, like so. Okay, so here we go. That's the first step. And also, since I kind of want to see what's going on, what I'm going to be doing is actually, did I close the stack? Yep, I did. Let me just boot it back up. Okay, so I actually want to have this view already, so let's go ahead and just put our camera in orthographic, and we are going to be putting it, say, right about here. So I'm just going to click here actually. Hopefully I can get the angle right, like so. Choose my camera. Once I have my camera chosen, I'll just go ahead and do game object align with view. So that's what I'm going to get. Now let's go ahead and turn this camera into a orthographic camera. Here we go. So that makes a little bit more sense. And let's actually change the skybox already. So Windows, lighting, none. Okay. So if I press on play now and actually start clicking, this is what I get. Now the first one seems a little bit weird. So which one is this? That's the last one on the index. It should have been moving this one first, but let's fix that a little bit later on. And what else should we be doing? Should we start doing the maths already? Definitely not. Let's go ahead and just instantiate some constant over here. So let's do a private const float, and this is going to be the bounds of the actual tile. So say you want to have 3 meter by 3 meter, this is going to be equal to 3.5, and that's going to give us a tile of 7 in the end. So let's go ahead and preview that. If I put my first thing on 3.5 in X and 3.5 in Z, that's actually the result we're going to be seeing in the screen. So that's something I could work with. Let's go ahead and turn all of them into 3.5 in scale X and 3.5 in scale Z. So that's our new stack right now. If we click on play and we just try again, then this still works. Right. Okay. So once we've got this out of the way, let's go ahead and return a boolean out of playstyle. Now if playstyle returns something false, that means we will lose. If it returns something true, that means we actually managed to place the tile. Whether it be completely like perfect tile, or if we lost a little chunk of the tile, that doesn't matter, it's going to return true. But if we totally place the tile away from the stack, then that's going to return false, and we can then use this to actually end the game. So let's go up here. If playstyle, that's when we press a button. So when playstyle is true, then we manage to increment the score and then spawn a new tile. Else, that means we lost. So let's go ahead and call another function that we haven't made just yet, endgame. And maybe just put it down here as well, private void endgame. Like so, and okay. So we can go ahead and just start spawning the tile right now. Or actually, you know what? Let's go ahead and move that tile first. So again, a new function called move tile that will just put in the update so it's being refreshed every single frame. Private void move tile. Right, we already written that down. And what else could we be doing in that? We could be doing, we could use a transition float. Let's go ahead and do that. Let's do a private float transition or tile transition. That sounds better. Now we'll just start on, say, 0. Now the movement we want is a fairly simple one, if I remember correctly. Okay, you see that over here? It just goes like this, so it goes from this side, and I think it can cross over if we just keep moving ahead. Let's see if he does it. It doesn't seem to do it, but I think I saw it a little bit earlier before, when the tile could actually go on the other side as well. There has to be. I'm pretty sure I saw it, that's why I'm being so... Okay, you know what? Even if they can't do it and they have to press a button, I haven't played the game, but even if they can't, what we're gonna do in our is we're gonna allow the tile to go from this side, so this place over here, then cross over to this side, and then it's gonna come back and just keep doing that until the player actually presses on something. Now to do that, I was thinking about doing the sin operation, so using sin. And it's going to be fairly simple, really. So we are going to go over to the move tile and have a speed as well. So let's go ahead and do private float tile speed is equal to 2.5. Oops. Let's try with 2.5. And what else did I do on this piece of paper? Right. So I use the time.delta time. Went over here and I said transition plus equal time.delta time times tile speed. And then what we've did is actually move the position of the current tile, which is the stack. The stack at the index, the stack index is moving is local position. Now it's really important to move the local position and not the actual world position, and the reason is because we're going to be moving the stack as well. So the stack is going to go down every time we add a new tile to it. So transform the local position is equal to a new vector 3, and then we did matf.sin, and we use sin tile transition times bound size, like this. So that's for the x-axis. For the y, we're going to stay on store count, and for the z, we don't really have any way to track the z just yet. We're going to start by just doing this on the x-axis, right? So let's go ahead and try this out, and hopefully everything works on the first try. Actually makes sense, right? It's a little bit too fast, and we obviously got something not working here. I think they're all a little bit too high, so I'm going to be moving this one shot like this. And then this is it. So it's moving way too fast, actually. And as you can tell, every time we press, we actually get this kind of result. So it goes up, and then the new one starts moving. So that's a beginning, I guess. And let's go ahead and just make this a little bit bigger for the bound size. So we did times bound size. I think we're going to do the, we're actually going to do sin, then tile transition, then times bound size. So this way we get the actual size of the bound. Because sin is always going to return something in between 1 and -1. So if we do that, we actually get a perfect movement with the bound size. So it actually goes all the way to 3.5. Now we could be adding a little margin to that as well, so maybe plus 0.5, but I don't really feel like it actually. It's going to allow us, actually it's going to allow our player to lose on the first try, which is something I don't hate. And what else could we be doing now? We could actually be saying, okay, are you on the X or are you on the Z axis? So private bool is moving on X is equal to, say, true at first. So we're going to go down to the move tile. If is moving on X, then let's go ahead and move this. Else, we are going to take this, copy it over to this side, and say, well, take all of this, then say 0, and then place it over here instead. Right. And we actually need to find a way to change the move. So in this code, where did I change my move? That's sometimes when I'm like in the car ride or something, I just go ahead and write code on a piece of paper, but it's not really readable. Right, okay, so in the move tile we've got it here, and then in the place tile, when we actually press on the button to place the tile, that's where I decided to actually say is moving on X, is moving on X is equal to is not moving on X, which is simply going to reverse value. Now I'll be putting this in playstyle. Now you know that playstyle is being called because we call it in a if statement. Even though it's using for evaluation, it's still going to run the code inside of there. So let's go ahead and press play, see what kind of behavior we get now. This is what we get. So we go ahead and we just No, we got both axes working right now. Now, obviously, in the game, this is not allowed. It should actually be placed on this over here. It should be like right on top of the other object. Now, in order to keep that position, what I was thinking about doing is actually have a float. So, another float. So, private float, secondary position. Simple as that. And secondary position, whenever I place the tile, I'm going to be setting it on whatever it is. So, secondary position. So, in case I'm moving on the x-axis, then the secondary position would be the z-axis. So, I'm going to say secondary position is equal to if is moving on x. You know what? Let me just put that before. So, if we're moving on x, then secondary position is going to be equal to the stack at the index stack index dot transform dot local position dot x, else the stack index dot transform. You know what, that's way too long to write. So transform t is equal to the stack at stack index dot transform. Right. So t at local position x and t at local position z. Right. Let's go ahead and try this once more. Actually, you know what? We gotta be using this, so I'm going to copy this, go over to the, where is it at? The move tile, and change the secondary position for both of them. There we go. Okay. So, pressing play now. If I click here, oh, there we go. So now it actually starts over there instead. And I can just keep going like this. Now, obviously, in a real game, then you would already be dead, so there's no point in going and keeping in, yeah, how do you say that? There's no point in actually handling that condition right now. Because a little bit later on, when we start cutting tiles and cutting our bounds, then this will never actually happen. Okay. Now, what else could we be doing? We could actually be moving the stack, because right now, if we go ahead and just try to play, then eventually we don't see our stack anymore. So let's take that whole stack and actually bump it down every single time we press any button. So I've got that written over here. What I've wrote, and it was transform the position is equal to a lerp in between the position and the actual position. So I did a little smoothing on this. And I'm going to need a vector 3 actually. Private vector 3 desired position, just like we do for the camera smoothing video. Now, desired position is being reset every time we actually create a new tile. So let's go ahead and see. Desired position is where the stack should be right now after creating a new tile. So after spawning one, I believe. Yeah, okay, so it's a really simple one actually. What I've written down is desired position is equal to vector3.down times the score count, which is basically, you know, in y. If you have 5 in score, then this is going to give 0 minus 5, 0. Which is the desired position of our stack. Not our camera, not everything else, only the stack. Right. And then in the update, we decide to move the stack. So move the stack right here. And to do that, we are going to say transform the position. So my position right now, and since I am the stack.cs, then this is my actual position. Now we don't have to use local position because we're actually the parent of this object is the world, so we can simply be using the position, the world position in this case. Let's go ahead and say new vector3, or never mind. Let's go ahead and say vector3.lerp in between my current position, so transform that position, and the desired position. Now as for the float, let's go ahead and just declare something else up here. So a private const float stack moving speed, I guess. I'll be putting on 5f. Now, where do we go? We go over here. Stack moving speed dot time dot delta time. Sorry about that. And if we just press on play now, we should actually have the stack moving every time we press on this button. And it does not work, so why is that? Actually, no, it does work. Sorry about that. Yeah, it does work. So, if we just take a look at the game scene right now, or the scene itself, every time we press on the button, it actually goes down. And now the rest is still aligned. Even though we move the whole stack down, since we're using the local position for these objects, they still look fine even though we're moving. And here we go. So now we have a moving stack, and it's always going to stay inside the camera range. Like this. It's always visible. Well, in this case, it might actually leave the camera if we just go ahead and try to do this, something like that, right? But again, this is something that is not possible with bounds. So when we have bounds, we won't be able to do that. Okay. Now it's pretty much about time to start cutting this thing. And to start cutting this thing, it's a really complicated algorithm, actually. Everything is going to take place in the playstyle. But it's going to be a lot of numbers that you might not necessarily understand. So I'll just go ahead and start, and hopefully we can tag along. So first off, if we are moving on X, we're going to take care of the X-axis first, right? So if we are moving on X, then we're going to calculate the delta in between the first position and the second position. So the first position would be the last tile position. The one that is below us. And then my current position would be my tile right now, right? So my tile right now is actually stored under T. So t.position.x, and on this side, we want to have the last tile position. Now, last tile position, we don't have that in our memory. We don't keep track of it, and we need to actually do that. So let's do a private vector3 again. Last tile position. Right. Now we can use this, so the last tile position over here in the playstyle, minus t.position, that's going to give us the difference in between my current and the one below me. Now, in this type of game, I think we want to have some kind of margin as well. So if you manage to stop the tile, you might have some kind of error margin. So maybe 0.1 when you're okay, right? You're not going to get penalized if you get minus 0.1, because else we'll never be able to combo like they do in the video. So I'm going to create a private const float again that I call error margin. Let's go ahead and put it on 0.1. And this is really, if you manage to stop your thing close enough, and like the position of the tile below you and your position is only 0.1, then we're just gonna assume that you placed it perfectly. Right. So let's go down here. So that's the position. Well, that's actually, you gotta be saying .x. That's a delta x, right? Now, if that delta x, and we're gonna use the mat absolute in this case, if matf.absolute delta x is bigger than error margin, that means we actually have to cut the tile. So cut the tile, and you actually lost your combo. Now we don't have a combo just yet, so let's go ahead and declare it up here. Private int combo is equal to 0. Right. So you have to cut the tile, so therefore combo is now equal to 0, and we should be setting the last tile position first. And to do that, if I remember correctly, I've put it somewhere over to the spawn tile. Oh yeah, right before we actually spawn a new tile, I've said the last tile position is equal to the stack index dot transform dot local position. Right. So now we have the the position of the tile below you, and then we spawn a new one. So basically we can keep track of that, and our delta should now be fine. Now we cut the tile. And should we start by cutting that tile right now, or should we resize? We should resize and reposition the new thing right now. And I've decided to use the local scale for that, not creating my own mesh, because if we create a new mesh now, I mean, that's a little bit pointless to create a new mesh when you can simply be rescaling your current mesh. But we're going to be creating a new mesh though for the rubble, the thing that falls off, because then we don't, we don't really have a choice in that case. So let's go back. I'm just looking at the notes I've took. Okay, so we reset the combo, then we actually reduced the bound, so we should be tracking the bounds right now. Do we keep track of the bounds? We have the bound size at the beginning, but we never actually keep track of my current bound, right? So I'll be putting that in a vector too, because we only need to know, okay, how big is our x right now and how big is our z? So private 2, let's call this private vector 2 stack bounds like this is equal to a new vector 2, and we'll instantiate it right away. So bound size and bound size. So as soon as the game starts, we're gonna have 3.5 in x and 3.5 in y that we can play with, and that's going to be the maximum as well. So I don't know if you notice in the gameplay, I saw it somewhere. Where's the video at? Right here. Okay. So at one point, when they're playing, they actually grow the bound size. I think it's right there. Yeah, you can actually tell that the stack is actually growing. So we can keep track of that with the stack bounds and then stop it once it's past its actual bound size, right? So we are going to go down to the playstyle and actually reduce that. So we're on the x-axis right now. Let's do stack bounds.x is minus equal to matf absolute, the absolute delta x. So we're reducing our current bound. Then once we reduce that, let's do the def check. So if stack bounds.x is smaller or equal to 0, then we're going to return false. We're not going to be calling endgame from here, because if we return false, we're going to end up calling it anyway. And this way it gives us some kind of margin we can play with a little bit later on, right? So once we did that dead check, we are going, and that's where the mat comes in, and they're a little bit annoying. We're going to declare a float that we're going to call middle, and we're going to get the middle point in between the current position and then the last position. This one is quite simple, so we go like last tile position dot x plus t dot local position dot x divided by 2. Right, so we've got the middle point in between these two. Now after that, we got to be modifying the scale. So t dot local scale is now equal to a new vector 3 with the stack bounds dot x. So where is it at? I don't know why I don't get it in the IntelliSense. That's a little bit annoying. So stack bound dot x, we always keep 1 because 1 is, that's the size we're going to be keeping pretty much forever in y. We're never actually modifying that, so we can leave it on 1 here, and then stack bounds dot z in this case, or y, sorry, there's no z in that. So this should work. Is equal, of course, we're not doing this way. And then once we've done the scale, let's actually try this out. Hopefully everything works. Actually, should have tried that before. Okay, so let's take a look at what happened. Basically, I'm going to try and stop this as close as possible to the ledge, and this is what we got. So this is pretty much believable. What we've did basically is if I press stop now, okay. So we took the position right here minus the position in the middle of this tile. So in this case, let's say 3, right? So we took 3 minus 0 in this case, and it gave us 3. So the size got reduced by 3. In this case, it would have been 0.5. And is that good enough? Let me just copy this over. Stack was 0.5. And as you can tell, it's actually perfectly what should be left over. So we've got position 3 on this one. We've got position 0 on this one. And we reduce the scale by the delta in between these two. So the delta in between this tile and this tile is 3. Then we reduce the scale by 3, which gives us 0.5. And this is exactly what should be left over. And I think we actually do the resizing. So we do the rescaling properly. Now we just gotta do the repositioning. And this one is going to be a little bit more annoying. So t.local position is equal to, and that's where we use our middle point. So is equal to middle minus last tile position dot x divided by 2. That's what I've written down. Now hopefully this works, and I'm simply going to write it really quickly, and hopefully it does. Else I'm going to have to pause the stream, which is a little bit weird for a live stream. And actually look that up. So I'm taking the position in the middle. Let's actually hope that this works, and we're going to theorize on that right now. So we're going to take the position in the middle, in between these 2 points. So if we're on 3, that would be 0. It would be 1.5. I'm actually going to copy and do it over here. So 1.5, and then if that's on 3, then that should be 0.5 in width, like so. So that's the middle minus last tile position dot x divided by 2. Why do I need that actually? Last tile position in x divided by 2. Last tile position is this one divided by 2. It's going to give us the same exact result. But then if it was over here, last tile position, which is 1 divided by 2, and we do a minus, so that would be minus 0.5. So he would be at 1 right now. Or maybe I get all my things wrong. Let me just try. Doesn't seem to work anymore. That's kind of weird. So this seems to work just fine for the first one, but then after that I'm not sure if it's going to work still. Oh, it's because my stack bounds is now smaller than 0, so instead of... I'm actually going to mute this really quickly. Okay, I think it makes sense, but my stack bounds is a little bit messed up. So I will uncomment this, and what else could I be doing? I could be starting to actually work on the else statement. So that's when we're moving on the not on the x-axis, but on the z-axis. So if we're not moving on x, I'm simply going to copy all of this and say delta z is equal to last tile.z t.position.z, and then we're moving this to delta z again, stack bounds.z z. Stack bounds is actually on the y, my bad. Whoops, like this. But the positions are on z, okay. Oh, not this one. Okay, this one has to be on x, but then we come over here and we say middle minus last tile position.z divided by 2. Assuming this logic is correct. And we're going to see that in a really short moment, actually. Okay, obviously got some error over here. Let's go check them out. So last opposition.z to local position. Okay, that works. The scales works on both sides. Wait, does it work on both sides actually? Okay, that's a little bit annoying. Now it does make sense on this piece of paper, but apparently I'm not correct. So let me just go ahead and look at this. Hopefully we can find a solution really quickly because this is live. First one works. This one doesn't work. Okay, so why does does this thing not work? It actually reduced the size. Oh, okay, I get it. Stack bounds dot z dot y over here. I was reducing the wrong axis on that stacks, so let me just try that again. And wow, okay, so that was the only problem. Nice. That's a little bit annoying. Well, at least we got this out of the way, so that's a good thing. Now, since we return false but we don't do anything, let's just go ahead and code something in the end game, so we know when we can't play anymore. And let's just write lose. Right, and why not do something funny as well? Let's go ahead and do the stack at stack index dot add component. We're gonna add a rigid body to it, and by default this has gravity, so we shouldn't be able to well, we should be able to, no, we're not actually, what's going to happen? It's actually going to fall, right? So let's try this once more. Lose. We can't add this because the component is already there. And does it have, yeah, it does have a rigid body because it's acting a little bit weird, but then we should stop our function move tile. So I'll just go ahead up here in the bool, private bool is dead, and is dead is equal to false. Actually, let's call it game over. Game over is equal to false if game over is equal to true. Oops, if game over is equal to true, then we're gonna return from the move tile function. And now obviously in the end game we're gonna say game over is equal to true. Okay. Okay, so this is what happens when we actually lose. So the tile turns into a rigid body and just falls. Okay. Now, we actually need to change the scale of our object in the spawn tile, I believe. Spawn tile is the moment where we actually put our tile back up, and at that moment we should be changing the size of it. So if we just go take a look at what I've written down, okay, so we're taking the stack bounds. Of course we do the exact same thing we did over here. Let's actually copy this function over. So we're gonna go over to the spawn tile, and I think we do it after position. So we're gonna say the stack dot transform dot local scale is equal to a new vector 3 using the bounds out we actually set beforehand in the playstyle. And here we go. Right. Then we lose. Okay, so does this work on both axes? It seems to work on both axes, so that's a good thing. And what is that? Let me just go check. I think we have a small arrow here. So here, we actually moved a little bit off and it didn't cut it. Because I think that's in, yeah, that's our error margin. So you remember when I said you have 0.1 in between this one and this one. So you've got 0.1 that you're allowed to fail. And when that happens, we should be actually moving our thing back. So we should be moving our object back and just snap it back to this one. So we're also going to have some else statement in here. So if we're moving on X, we're going to have a else statement in the okay, this is where you fell, and say you succeed. Then if you succeed, well, first let's go ahead and increment your combo. So combo plus plus, and then we're going to take your local position and just I think we can simply copy this over. I'm not sure. We don't have the middle. Okay. Should we rescale? We should not be rescaling because we don't actually cut it off. Let me put the middle in there like that. And I think we should be fine actually. So copy this over for the z-axis as well. Now obviously we're going to need to take this one instead. Like so. And middle is going to be something else, of course. Now let's go ahead and hit play. Hopefully we haven't broken anything. That'd be really bad. And how are we going to test this out? Oh yeah, we still get the error because of this over here. We can tell that it's not correct. So obviously if that is the case, then we actually only need to move the tile position back to the last tile. Now that I think about it. So what about we forget all of this and we only say, okay, so t.local position is equal to last tile position. Let's try that. Should it be on last tile position? No, it should actually be on last tile position plus 1 in the y-axis. So last tile position plus vector 3 dot up. Let's try this out. Let's actually take this and just put it in the x-axis as well, like so. And now hopefully everything works. Let's go ahead and play this. Yeah, I think it works. We actually don't get that little glitch that we've had before. Okay, so we're just gonna assume that this works because it does. I'm pretty sure of it. Because we don't have any imperfection in between this one, and that's only normal because we set it to the same position as the one below that, and it never changed size. So basically, it can't be wrong. We set it at the same position, but we do plus 1 in y, so it actually goes up instead. And that works, so, yeah, okay, right. Good. Now, what about whenever we have a certain amount of combo, we actually grow in size? We could be doing that right now, and wait, what was that? That's actually really bad. Okay, so if we get a perfect on the first one, we actually get this glitch. Oh, so we can't really allow that. Because the score is not incremented before that. So we're gonna say is equal to a new vector 3, last position dot x, score count, and then last tile position dot z. That's gonna work a little bit better, I believe. So let's put it down here as well. Okay, and then we should be good to go. Now we increment the combo over here, so before that, let's actually say if combo is bigger than, say, after 5 combo, then you get an incrementation on your stack bounds. So if combo is bigger than 5 and you enter this else statement, that means you actually successfully place the tile right on top of the last one. Let's go ahead and say stack bounds dot x in this case, because we're moving on the x-axis, is plus equal to 0.25. Let's make a constant out of that. So up here, private const float, we are going to say stack bounds gain. So 0.25, and let's actually say something else for the combo. So private const int combo start gain. That's on 5. Okay, so if we go back to down here and we go like, okay, if combo is bigger than combo start gain, that is 5, then we're going to increment that by what was it again? Gain, had the word gain, oh, stack bounds gain, like this. But now if we do that, that means we actually modify the scale of the stacks. So we need to also modify the scale over here. How are we going to do that? Should we just do this? I think we can just copy this over down here. Yep, so I'm going to take all of this and copy it in the z-axis as well. So over here. Now stackbound.y is plus equal to this, and then the middle is on the z-axis. For both of those, stackbounds.x, that works. Tile position. Let me just copy this one over. Like so, okay. Now, technically this should work. I haven't tested it out. Let's go ahead and do that. So if I get 5 perfect, then I should be able to have some gain on my stack size. And it's going to be actually fairly hard. Let me go ahead and increase the error margin. I'm going to be cheating a little bit. So error margin is going to be on 25. So that's 1, that's 2, 3, 4, 5, and then I should start gaining size. There we go. So my stack is actually incrementing in size in both the x and then the y axis, and then so on. And it makes the game way more easy. Now I failed my combo, as you can see over here. I failed my combo, so I gotta get 5 more in order to start gaining size. And then I'm back at 0 again. And it just keeps going like that for a while, actually. Okay, and I failed again. So basically we tested out, this works. Let's go ahead and put the error margin on say 1, and I started a combo in 3, why not? Okay, so we've got this now, and the incrementing works. By the way, the incrementing, let's make sure it never actually goes beyond its actual start point. So stackbounds.x, if that is bigger than the bound size, then let's say stackbound.x is equal to bound size. Same thing for the z-axis, or I mean the y-axis in this case. So over here, stackbounds.y, like this. Okay. So what else could we be doing? I'm almost done with my coffee, so I might actually need another one. I can't get it right, that's the most annoying part. Okay, so 1, 2, 3. Oh, I reduced the error margin, so it's a little bit harder too. So 3. I failed again. Okay, testing this could take forever actually. You know what? Let's not. We're going to test it at the end. If we need to come back to this, we'll come back to this. But I think this function is a little bit messed up. If I had more time and I wasn't such in a position where I don't know, I'm kind of not used to streaming, I guess. If I wasn't like that rushed, then this function wouldn't be, it wouldn't be 70 lines. That's way too much. Anyway, it's there, it's working. That's a playstyle. Let's just collapse it, right? I don't want to see it anymore, right? And spawn tile, this seems to work just fine. Move tile is cool as well. We get a def condition if we lose. We get an increment condition if we get a combo. What else do we need to do if we go back on the preview? So we've got this mechanic going on. Oh, the rubble. Oh my god, yeah, the rubble is going to be a little bit of a pain. but I've also written some stuff down for that as well. So I remember thinking about this really long time in the ride back home. So and we actually have a new function now called create rubble. Now create rubble is going to take in parameter a position in a scale. And I remember thinking about this for a long time, but rubble is not going to be children of the stack. It is actually going to be a thing on its own, so a game object on its own. So and it's going to be made out of cubes. So what I said is game object geo, store that inside of a value, and then I am going to create a primitive. Okay, so game object dot create primitive, we're going to create a cube. Primitive type cube. Okay, and after that, of course, we are going to do transform dot local. No, that doesn't work. Okay, so transform dot actually local works as well, since the parent of this is the world. Therefore it would be the same exact thing as using the local position. So local position is equal to pos, then transform local scale is equal to scale, just like this. And we also add a rigid body to this, so let's go ahead and do go to add component rigid body, so it actually looks like it is, you know, it's falling, right? Now the only problem I had with this function that took me so long to just figure out is what exactly should I pass in parameter, and took me a really long time, and I actually ended up putting it inside of the worst function we have, so the play style over here, and I actually put it in between the local scale and the local position, just like this, and I'll explain why in a second, because it took me so long, right? So the way I was thinking about this is if I just put this on hold and let's talk about what happened. I was actually like trying out some cases, and I end up with one that made me realize something. So say we actually end on this, right? We end right here. That's 2 in x, so we should be losing, we put that up here. That's 2 in x, so we should now be on 1.5, and we should be moved right about there. So that is my object we get right now. We already have this object. Now what I had to create is this one, the one that goes on this side. This would be, since this is 1.5, this would be 2, right? And then we move it over there. So that's 2.75. Okay. Now, how exactly am I going to end up with 275? 2 in scale is easy, because all I gotta do is look at this one and I say like, you know, what's the remaining of the bound size minus this? That's 2. That's easy. But then after that, how am I going to get 2.75? And I actually end up with a really weird one that says you're going to take the position of the first object, so this one. Then you're going to take the position of the last tile. Actually, not position, the scale of this. You're going to divide that by 2. So if we try, that's 2. And that's 3.5. 3.5 divided by 2, that's 175. And you're pretty much just going to put them together. So 2. Oh wait, no, that doesn't make any sense. So I've written down, what is it? The position x of the first one, the local scale of this one. Okay, yeah, my bad. So this is why I put the local scale first, and then I create my rubble, and then I put the position afterwards. So I'm taking this one, the one up here, and I say, okay, take your current position, that's 2, then increment it by half of the size. So I gotta be doing the local scale of this one first. This one now is now calculated, it's on 1.5, and I gotta be saying 2 plus 1.5, which gives me that's not it. Oh, divided by 2. Okay, so 2 plus half of this size, which is 75, which gives me 275. Enough just rambling, right? Let's go ahead and just do it, right? So it goes something like, okay, so new vector 3, we're on the x-axis, so new vector 3, and we need to do our big modification over here, and this is going to be a really awful line. Let's go ahead and do t dot position, because we have the t transform over there. T dot position dot x plus t dot local scale, since we haven't modified, actually, since we've modified this on the line before, divided by 2. So I'm going to put these two in parameters, in parentheses, and there we go. That's the x position. Let's not mess around with that too much. And let's go ahead and check for the t dot position, and that's the position on the y. I'm actually using the position here and not the local position because, you know, the stack moves down, but this is not part of the stack, so I need to use position and not the local position. And then for the rest, let's go do, I think it was position. I have it somewhere here. Yeah, to position in z, so it doesn't really change. Position in z. Okay, but now create rubble takes in 2 vector 3. That's the first one. Comma, and that should be the second one. That's the scale. Scale is fairly easy. All we have to do is take the absolute, so we are going to take the remains of what we actually caught. So matf.absolute delta x, I believe, delta x. As far as the y goes, it's always on the 1, and then take the local scale in z. Since this one doesn't change, even though we modify the scale over here, it never actually change. It could be stack bounds on y if you prefer. And that's it. Okay. Right. Create rubble. Function is being called. Let's try this out. Okay, so float cannot be applied. Oh, scale.x. This actually works. I'm quite happy about it. Nice. This actually doesn't work. I'm not mad, but I'm not happy anymore. Okay, so it seems to work on this side. But on the other x side, it doesn't work. Well, it actually looks like it's working. See, that was fine, but if we put it over here, yeah, it's on the wrong side. It should have been falling on this side. So why is that? Oh yeah, that won't work, so we need to fix that. Okay, so it's obviously on the x-axis, so this is wrong. What else could we be putting here? What if we do minus? I'm just trying stuff out, guys. Sorry about that. That was actually quite clean. Okay, so what if t.position.x was bigger than 0? If that was the case, then we'd use this, and if that wasn't the case, then we'd use t.position.x minus t, which is exactly the same thing, but I just inverted the plus sign. Can I do that? Does that look really confusing? Because it is. That's really confusing. Let's try it out. So, going to press play. This worked fine. This worked fine. So we're only looking at the x-axis right now, and it's working perfectly fine. Good. Let's do the exact same thing in the z. Why not? So we're gonna take this whole create rubble thingy function and place it right in between the local scale and local position of this function. So we're gonna be saying if t.position.y is bigger than 0, then we modify these two for y, local scale for y as well, but we should be using z in this case. Should we be using z? Yeah, everything is on z, never mind the y. I don't know why I put that there. Or actually, you know what? I'm completely wrong right now. this should be t.position.x, and in the z-axis, this is where we actually do the weird stuff, right? So what's the weird stuff already? It's all of this. So let me just put it in there. Try to format it as best as I can. But I don't have a lot of choices here, so let's do Z, let's do Z, Z here as well, local scale, ZZ, okay, cool. Let's try it out. It didn't seem to create any rubble. Why is that? Yeah, it didn't create anything. If we looked at the oh wait, I'm still at the wrong place. Am I? What? Cut the tile. Well, why do we cut the tile? We don't actually cut the tile in this one. Whoa, that's completely wrong. Oh, I'm completely at the wrong place. So sorry about that. I should be. This is why you don't have code that is that long, because you get confused. So if we're moving on X, that's fine. Let's get the else statement of that, and then we position ourselves over here, like so, and this becomes delta Y, I mean delta Z. And now it should work and make more sense. Yeah, so it's getting really confusing with the code. Try not to confuse yourself if you're actually following this. Yep, so this worked perfectly fine. Now try to win when you're at that point. It's fairly hard, I believe. I got it. Right. Okay. Good. So a good thing done. We've done the rubble. We've got pretty much every mechanic that we should get in this game. Let's go and code some colors. Why not? It only needs some colors now. Alright, so let's do it. As far as the color goes, I think I'll be lerping in between 4 different color, and wow, we have a lot of fields. This is going to be our first public field. Let's do a public color array, color 32, because that's less expensive on the CPU. So color 32. And we're going to say game colors. Right, so game colors is going to be an array of, say, 4 colors, like this. And we're going to be lerping in between those, so let's go ahead and just create a function for that. A private color 32 lerp 4, like so, and we're going to take in color 32A, color 32B, color 32C, and color 32D, plus a float that we're going to be using as transition, so I'll just call it T, right? So if T is smaller than 0.33, let's return color.lerp in between A, B, and we're going to return T divided by, does that work? Should we divide T by 0.33? We should. Else, if T is smaller than 0.66 in this case, because we only need 3 if condition, because we have 4 colors and every lerp is taking 2, so we can go like from AB to BC to CD, right? And we do a return color.lerp, and we turn B, C, and T divided by 0.66. That's not actually going to work. Okay, so we say T minus 0.66 divided by 66. Alright, what? Let's go ahead and do 33. being a little bit confused with what I wrote on paper because I write so badly. And else color.lep. This makes more sense actually. Yeah, so that's a good way to that's a good way to do it. And then if we just proceed, so cd, we go like t minus 0.66 and then divided by 0.66. Okay, cool, fine. So what we're going to be doing with that, you're like thinking, oh, we're going to be changing the material, but no, that's really expensive because every single tile is going to need a material, and that's 12 tile basically, and 12 tiles, 12 materials means 12 draw call, and since you're on the mobile, then mobile is not going to like you very much. You shouldn't have that much draw call on the mobile phone. So what I'm going to be doing right now is I'm going to use this to actually set the vertex color of the object. Vertex color doesn't mean it's going to color your object. Vertex color is just some kind of value that you have in memory. And we are going to use a shader that I've already got there in my Visual Studio. And I'll try to explain it, but I don't really understand this language. So it's basically just a shader that is going to use the vertex color to actually draw the color on the object, like actual real RBG values. So with this in mind, whenever we spawn a tile, let's go ahead and just let's just go ahead and say the stack index dot, oh, we're actually going to create a function because now I'm thinking about it, it's going to be really messy code because we need to use it for rubble as well. So let's do private void color mesh, and we're gonna send it a mesh as parameter, just like this. So mesh, and then we need a array of vertices. So let's go ahead and do vector3 array that we're gonna call vertice, like so, is equal to mesh dot vertice, and then we do color32 array colors is equal to mesh dot, no, it's not equal to mesh dot colors, actually is equal to a new array of color of vertice dot length, like so. And then for each of those, for int I is equal to 0, as long as I is smaller than vertice dot length, we do I++. Now colors at index I is equal to, then we do a lerp here, so lerp 4 in this case, and let's go ahead and lerp game color, which is the array we declared up top. So game color at the index is 0, 1, 2, and 3. So that's 3, that's 2, that's 1. And what could we do for the lerping value? Now I was thinking about doing another sin, but sin has a problem. It's because every time you go to the very ledge or very bottom, it's going to stall at the start and end point basically, and that's not really cool. But let's go ahead and just try this out using a float. So why not float f is equal to matf.sin, and let's sin using the score count. So score count, let's say 0 to 25. That might be too much. So every time we increment the score, we're going to push our sin a little bit further, so it's going to go like this with waves motion. And then we can send this as the last parameter. Okay, so once that's done, we are going to say mesh, so the one we receive in parameter, mesh.colors, let's go ahead and use color32, is equal to colors, like so. And where can we put that now? We could be putting this in the spawn tile. So in the spawn tile, this is where we're going to be changing the color. We're going to say the stack at stack index dot get component. We're getting the mesh filter dot mesh. Okay, so all of this inside the color mesh function. So like so. Now this way we should actually be able to color that mesh, and we should do the same thing with the rubble. So where are they at? They are right here. We're gonna do go.getComponent meshFilter.mesh, and it should actually color our mesh. Right. Let's go ahead and try this. But now you're probably wondering, oh, nothing happens, and that's perfectly normal. And by the way, I think there's like an error with our create rubble on the z-axis. Yeah, there's definitely something wrong here. There's the big offset. But since we started doing the color, let's go ahead and finish that first. Right, so I've got this shader over here that I'll try to explain. I'll put that inside of my folder, create a new surface shader. And this is going to be the vertex color shader, or vertex coloring if you prefer. So let's open it up inside of MonoDevelop, and I've got it in my copy paste right here. Copy paste is not working when MonoDevelop has been open for so long, so let's go ahead and turn that off. Here it is. It's really small and simple, and we're pretty much just saying that, okay, you're going to take in the lighting, you're going to be taking the main texture as well, and you're going to combine with primary, which I believe, I don't know how to write this kind of shader. I only use the CGN and CGBegin one, but I believe that primary would stand for the vertex color. Now, don't quote me on this. But I've tried it out before, and this one works on mobile. So we've got the vertex color over here. We also need the material now. So I will go ahead and just create a new material. Let's call this stack matte. Why not? And the shader is going to be vertex color. Okay. Now I'll be putting this on every single one of those cubes. And can I just do that? Nope. I gotta be drag and dropping it on every single one of those. Okay, why not? Here we go. So they now all have the vertex color, and by default the vertex color is white, as you can tell. If we press play, we're now on black. The reason we're on black is because, oh, by the way, the rubble doesn't work, so that's something annoying. Well, I mean, the rubble doesn't work because it doesn't have our matte. I believe that it is also black. If we just pause the game, and as you can tell, if we just put the material on top of it, it's actually black. Okay, so the reason it's black is because our four colors, our game colors under the stack, they're public, and therefore they have this default value that is black. So I'm going to be putting it on, say, something like really cyan blue for the first color. Now, know that since this is a sin, it's going to stall on the first and on the last value for a little while, so make sure those one are really light colors and they're really like nice to look at, compared to the one in the middle, which should be more like, it should catch the eye a little bit more because they're going to be so fast. Okay, so now with these four values, let's go ahead and just play this game. And here we go. Okay, so we might want to decrease the scroll value as well, because this is going a little bit too fast and it doesn't really live. So but here it is. Basically these are the colors, and we need to actually fix the rubble. Now, how exactly are we going to fix the rubble? We're gonna simply apply the material to it. So I'll be creating a new public material that I'll call stack matte. Now stack matte needs to be assigned every time we create that rubble. So let's go take that mesh, and can we say material on that mesh? We can't. Okay, so does mesh filter? No, it does not have a material. I don't think so. Okay, so we're gonna need to leave that like it was and say go.getComponent, and then we need to get the mesh renderer component. This one has the material, so material is equal to stack matte, like so. Then if we press play, the rubble should actually have the same color as the Object on the side. Now we forgot to actually assign that, so let's go under stack, drag and drop the stack mat. Right. And there we go. Now I believe it's a little bit it's using the value from before, so can we actually fix this? Okay, so we place the tile and then we get the skull and then we create a rubble inside of playstyle. Let's actually try to do the, oh no, that's not going to work either. So I'm going to leave it there and leave it for the last kind of bug, so the polishing phase, I guess. Now what's going on? Why do we, what have we done? Okay, so let's not reverse that. Oh, I actually removed the whole function, my bad. Forgot about that. I don't know why I did this. And here we go. So okay, so we're back at this, and as far as the first one is concerned, we should be able to actually see it. Well, as far as the all the first style are concerned, we should be like putting a value on those. So let's go ahead and say for actually over there inside of that for loop, I'm going to open that up and say, okay, so the stack I transform the get child, that's cool. The stack I dot get component mesh filter dot mesh, and we are going to color this. So put that inside of parentheses and wrap it with the color mesh function that we've made. Press play. All of these should now be colored, and that's exactly what we'd like. Now, if you want to have a gradient on these as well, or well, a gradient, that's a way to tell. But if you'd like those to be colored in a different way, you could actually start by saying score. So the actual score count would be equal to transform dot child count, and we put a minus on that, and then we say score count plus plus every time, which is going to end up on 0. So you're going to have 0 in the end, since you're doing it as often as there is children's, I believe. Now, why is this not working? Okay. So I don't think that sin is taking a negative value, and that's a little bit weird. I don't know why it's not taking any negative values, but apparently it's not. So let me just put it on that just to try it out, see if that's really the problem. Okay, yeah, so that's really the problem. It's a little bit weird. So I'm going to remove this, and again, for the polishing phase, we'll be adding a gradient to the beginning phase. So that's only colors. We don't really need to fix that right now. However, what we need to do right now is fix this problem over there. The one where on the z-axis, our mesh actually goes at the wrong position, I believe. Okay, cool. So let's go ahead and fix that. We're gonna start by looking at the, where is it, the play style. Now play style, okay, we change the scale. I think the scale is fine. Let's just make sure. So is the scale fine when I press here? The size of that rubble is on 1.4 and this is 1.57. Okay, so yeah, it is supposed to be that big. Now so the scale is fine. We create a rubble at the position. Oh no, that's not good. I'm on the wrong function. So position in X is okay. Position in Y is always the same. Then we say my position in Z is bigger than 0, then go ahead and do the plus thing, and else you're going to do the minus thing. Should it be local position or should it be on position like that? What did I put over here? Did I say local position? No, I always use position for this because it's not on the stack. But maybe I only want to be using that for the y-axis because we're only moving the y-axis in the end. So maybe by saying local position, I might end up having something that works. I'm really just trying stuff out right now because I don't see where the problem is if it's working on the other axis. That almost worked, I guess. Okay, let's try now. Oh no, there was definitely a problem with the scale there. Yeah, the scale is wrong. That's the problem we had. So going to modify that back to what we've had before. I believe that's it. Okay, so that's on the X. X is fine. If we go over to the scaling, we say stack bounds.x. Okay. Delta z. So we decrement this by delta z. Delta z is the exact same thing as delta x, but using the position.z. Okay. Oh, okay, I get it. It's over here. It's in the create rubble function. The second parameter we send, we should be inverting this. So delta z goes here, and in this spot we say t.localScale.x. Right, and then we shouldn't be getting this error again, hopefully. And let's see how long we've been running on this. 1 hour 33. Okay, it might be a little bit too long. And my errors are getting really messy. Damn. Sorry about that, I guess. Wow, now it actually works perfectly, and it's actually quite fun for some reason. Okay. Good, so we've made it through all of that, and let's just test out a little bit more. This actually makes sense. We are going to start by, not start, but we're going to keep going by displaying the score. So let's go ahead and do that. Again, we're like in only one script, but we can do the job with that. We can work around. So public text is not included. Using Unity engine.ui. Public text score text. And the score text is going to be modified every single time we get a score plus plus. So where is that? Score count plus plus over here. So score text, that text is equal to score count to string. Okay, just like this. Now we actually need a text value, so I'm going to create a canvas, right click UI text. This is going to scale with the screen size if I want to be putting this on my phone. So scale with screen size. And what else? Oh yeah, we go in the text. Let's write say 54, why not? Now where is that text at? I can barely see it. Oh, there it is. It's really nice and clear. So let's bump the size up by quite a lot. You know what? Let's actually make it stretch as well on both axes. Going to bump the text size and also put it in the center like so. Now as for the text size, maybe 150 in this case. I'm not sure, depending on how big the screen is. And obviously we need to do some moving of the camera as well. So white color, do I have to put it in italic? Why not? Yep, so here we go. And that should actually be it. Right, so we start on 0. If I press on play, no reference because we forgot to actually assign that text. So score text, drag and drop like this, press play. 1, 2, 3, 4, 5. And I'm thinking it's a little bit too close, but what I'll be doing is just moving my camera at the proper place. So right now my camera is looking this way. Maybe if I put a rotation of 45 on it, this is also on 45, I can then move this using more exact values. So I've pretty much just reset my whole thing, my camera, to the original position. Now I'm going to use the local moving, so it goes like that. And is that nice enough? Is that going to work? I believe this is going to work, yes. Let's go ahead and lose. So what happened when you lose? I never actually saw that in the preview. I should have downloaded the game actually, but that's something I haven't done. So whenever we do lose, let's go ahead and just, pop another kind of menu, a really like simple menu, so we don't spend years on this game. And we are going to create a new UI. Let's go ahead and do a panel. That's going to take the whole screen. Should it take the whole screen? Yeah, why not? Okay, so it's going to take the whole screen. It's going to be the N panel that we can simply toggle on and off when the game is over. And this N panel is going to have a reference in here as well. So another public game object, and panel. And in the endgame function, which is at the very bottom of the script, we're going to say nPanel.setActive to true. Right. Now this function is also going to have a this panel is going to have a button that returns you to the main menu, or returns you to start a new game. So basically start a new game or go back to the main menu. So public void, let's go and do on button click, is going to stay taking a string parameter, which is the scene name, and inside of that we're simply going to change the scene like we do in the endless runner. So let's go back up using Unity Engine .scene management, and scene management around here. So we're going to do scene manager dot load scene, and we're going to load the scene name. Okay, now whenever we make buttons, we can simply plug them on this function and then give them a string parameter. So let's do that right now. We're going to add a new button, so right click on the End Panel, UI, button. Then of course we have to scale this up by quite a lot. So maybe 300, make this something big, 400 by 150, right? This is the retry button. Font size like that, italic, why not? Of course, the art on the UI is never one of my strength, as you could tell, but at least I try, right? So that's a retry button, and the next one is going to be, of course, the main menu button. main menu button. This is, we said, retry button, right? And main menu button. So much renaming. And what else can we be putting in here? Main menu. So just type in main or menu. Move it down. Oops. Move this button down right here. Okay, and then finally what we need to do is actually go on every single one of those. So retry button, on the button component, there is this unclick event down here that we can simply put the stack inside of that. So the stack like this, we go under the stack. Then there is a function called onButtonClick. And we go to the game scene, which is the actual scene. Now, as far as the main menu goes, we do the exact same thing. So drag the stack in there, the stack, onButtonClick, and this is menu scene. Okay. Now, awesome cold coffee, great. Now we need a menu. Right. Okay, so back in my project folder, I'll just put something for my artwork. So that's both my stack material and my vertex color. That's the smallest project I've ever seen, by the way. But it actually works. Why not? Game scene. I'm going to hit Control N on the keyboard. That's going to create a new scene. Then Control S to save it. That's the menu scene. Like so. And that is what we call whenever we're ready to actually, you know, play. Or actually when we're ready to see what's going on the menu scene. So Windows, lighting, like this. We turn this off. Let's create a really quick menu. A button, why not? So button that's going to be in the center. Position.x is like this. Width might be, before I actually adjust the width, let me go just change the canvas scaler for screen width scale size. Then I'll make this 400 by 150. I believe that's what I made the other ones. Let's make sure it's the same thing. At least we get some kind of consistency in the menu. That would be like a start. So 450 by 150. by 150. Okay. And then this one is a simple play button. So let's go ahead and just say play. Now, this is where you would have some nice splash screen and like a preview of your game and something of the sort. But I did not really want to make this. I actually want to make only the gameplay. So, on the art, of course, you're free to do pretty much anything you would like. You are the artist. You are pretty much what gives the image to the game. So, if you want to go ahead and just, you know, put a text over here and you're gonna do like me, that's perfectly fine. So I go here under canvas. I'll move that up here. That's going to be my splash screen right there. So the stack in capital letter, and then just bump this up. Make the scale. That's the best. That's the best splash screen you've ever seen, I bet. Boom, just like this. Okay, the stack. You press on play, you go in the game. Right, so in order to make this work, we actually need another script, so that's a little bit annoying. Create a new script, a new menu script. Oh, and we can also use this for high score, so why not? Let's go ahead and say main menu. That's sad, it pretty much breaks our record of only having one script for the game. So we're gonna have two instead. Main menu is going to be on the main camera because I feel like it. And main menu is going to have two function. Two functionality. First one being a public void to game, right, which is going to redirect us to the game. All we have to do for this one is use the scene management again. So using Unity Engine.scene management, we're going to say scene manager dot load scene. We're going to load the game scene. As simple as that. This is going to be linked to our button. And the next one is going to actually be loading the high score. So private void start. Let's have a reference to a text object, so why not just display the high score? You know, typical stuff we do in the other one. So Unity Engine.UI, public text score, score text, why not? Then we're going to say score text.text is equal to player pref dot get int. We're getting the score int like this, and this is actually going to work fine if we actually set a score. So whenever we do endgame, instead of saying debug.log lose, let's go ahead and say if player pref dot get int the score int, if that is smaller than score count, then that means score count is bigger, and that would be player pref dot set int, set the score int to score count like this. Right, now all we need is actually have a place to actually display that high score. So before I fix this little error down here, I'll just go ahead and just right click on the canvas, text, score text, make it scale on the whole screen, why not? Then put it down in the middle and say, oh, the text is going to be like 44, why not? 54. And why is it only that big? Oh, there we go. So there we go. So that's 54 right there. And again, really nice UI. I'd give it a 5 out of 5. Right. Now I just put something in there. So this is going to be a high score. When I press on play, I can't because I have this error. ToString. Right. Now if I press on play, I should actually have this working just fine. Object is not set to a reference, so we're going to go on my main camera where my script is. Score text needs to be equal to score text. Then again, if I press on play, our max score is 0. And I haven't made the button just yet, so let's go back on the button. Click on the plus sign, drag the main camera in there. Let's go for main menu and then to game. Okay, now everything should work fine. Press play. And it doesn't. Why? Why does it not work? My button doesn't seem to be interactable right now, and I think that's because it is in the wrong order. So if I put it at the very bottom like this, I'm able to click it. So I'm going to put it down here, and that's because my text size, my text rect transform is too big. So when I click, it's actually thinking that I'm clicking on the text. So if I put it at the very bottom, then it's the UI element that is very on top, and that's the one I can click. And now we get this error where it's not added to build settings. So let's go ahead and do that. Build settings. We're on the game scene. We're on the menu scene. Add open scene. Inside the game scene, same thing. We're gonna add this one, and I'm thinking about it right now. We need to turn off this end panel. So turn it off like that. And also the end panel needs to be added as a reference. So let me just put it in here as well. That's for the stack object. Okay. Now back in our main menu, we should actually have this working. So that's our game right there. I'm going to press play. Then I'm having a bunch of fun. Yeah. Okay, cool. Then eventually I die. Right? Right now, why not? And I've clicked a little bit too fast. That's really annoying, actually. Retry works. Menu works. Everything works. Right. There's something I'd like to do beforehand because we keep getting these error down here when we go to the menu scene, and that is because it's assuming we're creating something new, and that shouldn't happen. So basically, what happens is we click, and our click is still running something in the background. So we're gonna say under the update right here, if game over, then just go ahead and return. We don't need to do anything of that. And if I remember correctly, inside of the move tile, we can remove this one now, like so. There's also something else that we need to do, is the rubble that we create, we actually need to remove them at one point, because I was looking at this on the right. If the person is good enough, then you're gonna end up with a lot of rubble in your scene, and they all have a rigid body, and that's really expensive for the mobile as well. So as soon as they hit a certain point, let's go ahead and remove them. So again, create a new script. This is going to be remove rubble. Now, remove rubble could simply be a plain object, so why not something of like a cube that we put here, and we just make really big, why not? Now, where is our cube? Right about there, right? So we could be making this really, really big, something of the sort. Oh, we're in the we're in the wrong scene, sorry about that. So let's go in the game scene. So here is our stack. I'm going to create a plane actually. Plane should make a little bit more sense. I'm going to make a big plane just below that. So this plane is going to have the remove rubble script attached to it. It's going to be, well, it's not going to have a mesh renderer just like this, but the mesh collider is still there. And this one is way too expensive actually. Let's turn it off and put a box collider on it. So we have the box collider, and everything that touched it, let's just go ahead and destroy it. So open up the remove rubble script, and we're gonna do private void on collider hit, I believe. I always have to look that up, so let me just go ahead and do that. On collision enter. Okay, so on collision enter is what we should be using. Oh, sorry about showing you my stuff. On collision enter right there. Okay, so the function is, oops, oh, the copy paste never works. On collision enter, collision call. Okay, so this is what we get. It's going to be called every time something enters collision with this plane object that is actually a box now. We're gonna do call. Actually, we're gonna do destroy call. We don't even have to think too much about it. Call the game object actually. I think that should actually work. So let's try it out and look at the game scene. Yeah, so it's a way to clean this up. Of course, we could be reusing those objects, but that might be a little bit too freak, right? Okay, and even if they do fall on your stack, like this one, eventually they're going to be white because we're reusing the same tiles all over again. So if we just take a look at this, and we succeed a few times. Oh, I didn't make it. That kind of sucks. I was trying to show you something, but okay, this one is going to stay for a little while. So eventually it's going to be white because we're always reusing the same tile. So after 2 more tries, it's gone. So it's always going to clean up itself. And that's going to be pretty much it, I believe. I believe we just made a nice draft of this game. In how long did we take? We pretty much just took 2 hours for that, so we got a nice draft. Now, of course, we could be adding a background to this, so changing the camera color, why not? So under main camera, we could get a link to our main camera and just change the background color, add a small gradient over time, something like that. And what else could we do? We could also, well, make a menu scene that is actually, you know, that doesn't look like this one, and work on this, pretty much. But what I really wanted to show you is how to implement ads and push it to the Google Play Store. So Google has a console. This is the one you want to have. So it's called Google Play Developer Console. And these are all my apps. I only have one app that I published because I don't, I never really bother about doing one, but we're going to make one right now. So we are going to go ahead and just publish something. Our best that we can do is first build our game. That would be a really good beginning, and actually build it on the phone. So let me just fetch my wires right now, and we are going to build this somewhere. Oh, sorry about the chair making noises. It's a really old chair. And is the wire long enough to see this? No, it's not. Let me just unplug this then. Okay, so I've got my phone right here, and I'm going to be building this on my phone. So by hitting Control B on the keyboard, I actually get to open this menu. So on this menu, of course, you want to be choosing Android if you have one, iOS if you have an iOS, of course. And then before that, we're going to go under Play Setting, change the company name for N3K, product name for the stack, why not? Now, as far as the resolution goes, we'd like to be on portrait all the time because that's how the game is played. It's always standing, like this. And what else? The icon, I don't really care about the icon just now, sorry about that. But if you wish to have some nice icons, you can be putting it here. Splash image, also don't care. And the bundle identifier is something you need to put. So, com N3K, the stack. And I think that's it, really. Let's go ahead and build this. So, build and run. We're going to build and run, and we're going to be calling this a build.apk. So, after a little while, it should appear on my phone. And this might take a little while the first time you actually build it. Even though we only have, what? We have like 6 assets. We have 7 assets. That's like the smallest project I've ever did. But it only took 2 hours, so that's I guess that's a plus. Okay, so over here we've got the stack, the best game on the market right now. If we press play like this, oh, oops, I actually start failing already. So if we press play, we've got our game. Now I wish I could show you while I'm playing, but it's basically the exact same thing as we got on a PC. And it's actually way more fun for some reason. And yeah, so it works with the touches as well, and that's because we use input.get mouse button down, and this one works for both the mouse and the touches. So again, let's test the menu scene. We go back on the menu, that's the game, the stack. We've got a high score of 10. Then I'm going to try and play through that, and I've already failed, so that's really bad. Okay, that's kind of impossible, actually. Okay, let's try. Real try. Okay, whatever, right. Retry button also works, we just tested it out. And that's pretty much our game. So we've got the APK because we built it. If you guys remember, we actually, under this folder, if we hit show in Explorer, we actually get back to here. So if we go back one folder, here is our build. Actually, you know, where is our build? Where did we build that? Oh, build.apk is right there. So that's 19 KB, which is really nothing. If we go under the developer console, I am going to add a new application. Default language, English, why not? The stack, upload APK. Right. Then this gives us the whole screen where we actually should be setting everything properly, but since I'm kind of in a rush because I gotta go really soon, we're gonna do this really fast. So do I need a license key for this application? Yes, I do. So we're gonna do get license key. Actually, do I need one? I don't even know. Let's go and try without first. So drop your APK file here. Here is mine. Drag and drop this in Google Chrome because that's really nice. And it's uploading right now. Fairly fast upload. And let me just go check if my computer is dying right now because of the file of this recording. Yes, it is. Okay, you uploaded an APK that was signed in debug mode. You need to sign your APK in release mode. How am I doing this? Okay, so I'm back with a solution apparently on how to build this properly. It's under build settings, player settings, just like I've tried to do like a few times already. If you guys don't have a key right now, you need to create a new key, and that is something you need to keep. Don't lose that key, else you can't update your app, or you can't even prove that you're the person that made that app, so you want to keep that key at a safe place. So basically what you're going to do is create a new key if you don't have any, then you're going to browse a new place where you can save this. So my key that I must never lose. You save it somewhere, and then you enter a password down below here. So just say a random password. Well, you gotta remember that password as well. That's as important as keeping the key. So once you've got this, then this is going to be the key down here is going to be not highlighted, but you're going to be able to click it. Now I already have my own key, so what I'm going to do is actually fetch my own key somewhere here. Okay, so that's my own key. Just imagine that you're creating a new one. It would be the same exact thing. So now you have access to this, and then you're going to create a new alias. So I already have one game on the App Store, and I've created this new key for the stack, right? So if you don't have this, what you should do is go under create new key, and then you fill in all that information right there. So your alias, my game, password, they don't match because I can't type. Validity, you say 50 years, that's fine. First and last name, of course you want to be setting this to real information because that's pretty much just what proves that you've made the game. So also the unit, the city, state, and country code, which, you know, US or CA or PH or whatever you'd like, right? Well, not whatever you'd like, but whatever your country is. Once everything in that is done, you're going to create a new key. Now I'm not going to do this because this is going to mess up my key store basically. So I've already created mine. You're going to choose it from that menu. It's not going to be like highlighted by itself. You got to be choosing it right here. So go down, go in your game, your alias, and type in your real password again. Once this is completed, you are now going to build your game once more. And it should now be built under this key, so the stack key. And if we go back to the play market over here, I'm going to hit upload a new APK, drag and drop this new one, and hopefully this time it works. I'd be unhappy if it didn't. So, let's have a look. And it did work, so here we go. So that's it. That is pretty much the window we get for our game. Now, a lot of information to write in here. You gotta be saying like, okay, that is one for production. You can actually launch this one. Then it, the screen is big enough and it's pretty much self-explanatory. So, you know, you gotta be going under store listing, and this is the exact same thing you should see in the store. So, clone of the stack game made for a YouTube stream. YouTube VOD, let's just say that. Full description. It's up to you. You just put whatever you feel like putting. Graphical asset is important. It's a must. So you need to have some graphical asset to put in there. So you keep adding all of this. Application type. It's a game. It's an arcade game for everyone. Website if you have any. Phone. Don't look at my Gmail. Thank you. And privacy policy, which is pretty much your privacy if you have one, if you have some kind of ULA. So yes, you want to save this, so save draft. And you're just going to keep on filling all of this information until all of these green checkboxes are lit. So basically this one isn't lit, so that means I still got to put some information in there. In this case, you need to add a iris icon, you need to add feature graphic, you need to add all of these. So that is why it's not on green right now. Now content rating, same exact thing. So you go under here, and it says, please enter a valid email address. So I think you got to be filling this on your email address. So I'll just go do that right now. Then choose that this is for a game. Does the game contain reference to violence? No. Doesn't have any violence. Fear? Nope. Sexuality? Nope. Gambling? Nope. No language as well. No substance. No crude humor, and then a lot of miss questions. So you can't exchange content. It doesn't share information. It doesn't share position. No digital goods. No Nazi symbols, okay. No this. Okay, so we're pretty much clean. We saved this thing. And once this is saved, I think it should turn to green. Or it doesn't, but actually this part is done. So it says item not completed. Why? In progress. Why is that? Calculate rating. Okay, so it's going to give you a rating, then it's going to save. So this is my rating. It's pretty much open for everybody. Then apply rating. And here we go. So this one is done. Pricing and distribution. This application is free. It is for Google Play, for work, I guess. And it is available in pretty much all the country. Why not? And we're going to say it contains ad. It does not right now, but we're going to say that it does because we plan on adding some in the future. We don't want to be putting this on Android TV because it's not made for that, and we've got the error sign as well inside of Unity, so let's not do that. It's not for education either. You can decide to opt out of Google Play advertising, so you're never actually going to be on the front page if you decide to hit that. This application meets the content deadline guideline, yes. Export law as well. Okay. And you're going to save draft. And you're pretty much done for the pricing and distribution. So the only thing we're missing right now is really just assets, I guess. So you need to upload some photos of that. Let's take a quick look at what we need. So a high-res icon, that's 512 by 512. So we're going to be booting Photoshop. And I'm simply going to take a really fast picture. I'll remake those after the stream is over, but right now I just want to get this done. So here is my 512 by 512 picture. Gonna go inside of this. Oops. And work with a print screen. So basically here is my picture. Right, so save this, save as, and I'm going to save this under my folder for this game, which I believe is right about here. So let's go ahead and create a new folder for Google Play. And now I've got my 512 by 512. If I go under Stack, Google Play, here it is. What else? We also need a feature graphic, which is 1024 by 500. So let's go ahead and do that. 1024 by 500. And I don't know, you're just going to be doing whatever you wish to do at this point. It doesn't really matter. So why not do something of the sort? Oops. Of course, you could be spending a lot of time in making this look pretty, but that's what I'll do. Right, so that's the best graphic you've ever seen. Save. What is it? The feature graphic. Promo graphic, you don't need one, so I won't do it right now. Promo video, same thing, you don't actually need one. Okay, it's a game, arcade, has a content rating, email. You actually need to put your email on the Google Play Store, but you guys already saw my email, so I don't really care at this point. And you also need to check this privacy policy, right? Once that is done, if I do save draft, do I get to publish this? Not yet. And why is that? Let's go take a look. So that's for the phone. Okay, for the phone this works. Oh, you're also going to be putting for the tablet as well, I think. I'm not sure. We're gonna hit on why can't I publish up here, which is going to tell us exactly what we need. So it says you need at least 2 non-Android TV screenshots. So we're going to be taking screenshots of our game. Let's go ahead and hit play. That's a screenshot right there with my cursor in it. Maybe not. So that's... There we go. So screenshot right there. Again, I'm being really fast with this, and this is not what you should do at the moment you upload. I'm repeating myself. You should not do this when you upload your thing. Actually take the time to make nice graphics. And yeah. So let's make those pictures say 400 by... Actually, what's the resolution of my portrait game? We could be saying 3248. Like so, and then I'll just put that here. So that's one screenshot right there. And we need 2 of those, remember? So you're going to be putting another one of the menu, the really nice menu we've made. Okay. And SS2. Right. So once we're done with that, we're going to click add those 2 pictures like so. And then I think we're going to be good to go. So save draft. and it's ready to publish. So finally guys, we made it. Let's hit publish app. I am going to sign off because we've been at it for like 2 hours and 30 now, which is actually fairly quick if you think about it. We've made a game in an afternoon and we've published it as well in afternoon. The only thing we need to do now is actually put ads, and we could be making some kind of profit on that, but I'm kind of hesitant on that actually. To be honest, I don't want to be putting ads on this game because it's obviously something we ripped off somebody else, so that's not something really cool. You don't necessarily want to be doing that, but we're gonna have another video that talks about adding ads to games, right? So I will pretty much end on this, and what is this? That's the screen, right? We'll pretty much end on this, guys, and like I said before, we're going to have a VOD of all this. Hopefully you guys can look at it and actually follow where you pretty much lost the cap, because at one point we were going quite fast. And if you want to make this tag game, then that's how we do it. That's one way we do it. There's probably another way to do it. There's 1,000 ways to do this, most likely, but this is how we tackle the issue. So I hope you guys enjoyed, and I will now sign off, do my things, and fix this game, add a nice menu, add some description on the Google Play Store, and I will see you guys in the next live stream. Alright, thanks a lot for tuning in, and I will be seeing you next time.